Welcome to all. Myself is Savitri Bennur. I am studying in BS second semester. My subject combination is chemistry and mathematics, and my seminar topic is conformational analysis of ethane and butane. Now I am going to explain about the conformational analysis of ethane and butane. Conformation can be defined as one of the infinite number of a spatial arrangement of an atom in a molecule that can arise from the rotation around a single bond. And the process of analysis and evaluating such a structure is called a conformational analysis. Conformational analysis can also be defined as these are the isomers that can be converted into one another by rotation around a single bond. There are two extreme forms in a conformational analysis that are staggered conformation and eclipse conformation. They can be represented by Saurs and Newman projection. Let us see the conformational analysis in ethane. In ethane, there is a single bond between a carbon-carbon atom. It is called a sigma bond. According to the definition of a conformation, ethane continuously undergo rotation, resulting in a different spatial arrangement. Ethane has a 2 carbon atom and 6 hydrogen atom, and this is structure of ethane. Let us see the Saurs projection for ethane. In Saurs projection, the carbon atom at the left of the structure is considered to be closer to the observer than in carbon atom at the right. If the rarer carbon and their hydrogen are exactly behind the front atom with a 0-degree dihedral angle, and this structure is called eclipse conformation. If the rarer carbon rotates 0 degree to 60 degree, then that structure is called a staggered conformation. Newman projection for ethane. Newman projection is a convenient way of sighting down a particular carbon-carbon bond. Here we can clearly see the difference between eclipsed and staggered form of a structure. In eclipsed form, dihedral angle is 0 degree. When the rear carbon rotates 60 degree, then we get the staggered form of a ethane. Staggered conformation of a ethane is more stable than eclipsed conformation of a ethane, because whenever carbon rotates 60 degree, in that condition torsional strain is less. Let us see the conformational analysis in butane. The structure of a butane is CH3, CH2, CH2, CH3. Consider a butane has a 1,2-dimethyl ethane. Saurs projection in butane. In eclipsed form, the rarer methyl group is exactly behind the front methyl group. When it rotates 60 degree, it attains the staggered form. Newman projection in butane. There are 6 conformations. When the rarer methyl group is exactly behind the front methyl group with the dihedral angle 0 degree and 360 degree, and this structure is called a fully eclipsed structure. Continuously 60 degree rotation of a rarer carbon atom forms the 6 conformation of butane, that are Guche conformation, partially eclipsed conformation, anti or fully staggered conformation, partially eclipsed conformation, Guche or skew conformation. In those structures, anti or fully staggered conformation is the most stable conformation of a butane. It has a 2 methyl groups of a 180 degree away from each other. Gauge or skew conformation is a staggered conformation with the methyl groups 60 degree apart, although it has no eclipsing interaction. It is 3.8 kJ per mole higher in energy than the anti-conformation. This is due to steric strain. Let us see the graphical representation of a butane's conformations. Relative energy versus dihedral angle theta. 16 kilojoule per mole energy required to convert the anti-conformation into eclipse conformation. 3.8 kilojoule per mole and 19 kilojoule per mole required to convert the partially eclipsed form to skew form and skew form to eclipsed form respectively. Stability according to their structure. Anti-conformation of a butane is more stable than skew conformation of a butane, and it is more stable than fully eclipsed conformation of a butane. This is all about the conformational analysis of ethane and butane. Thanks for watching.